Now, this section is meant to be 1.5 days. So, but it actually will be a little bit shorter, um, mainly because it's time wise, it just didn't, it's not, it won't take 1.5 days. So, section 11.9, representations of functions. And we're only going to deal with one for right now. This whole section's just about one function. And I call it one power series to rule them all because I like Lord of the Rings. All right. So let's suppose that you have a function that is x to the nth power. Or I'm sorry, that is the summation of x to the nth power. Well, if that converges, and I'm trying to avoid the punchline, if the summation from 0 to infinity of x to the nth converges, the only way that's going to happen, if you think about it, that's x to the nth, that's a geometric series. You don't realize, but it is actually a geometric, it's something to the nth power, right? It could be a half to the nth power, or it could be 5 to the nth power. But if it's 5 to the nth power, it won't converge, right? So this converges only if the absolute value of x is less than 1. We know that from section 11.2, way back when. So we know that this power series, even though we didn't call it a power series back then, we called it a geometric series, but this power series converges only if its common ratio is less than 1 in magnitude. And by the way, if it is convergent, we know it converges to 1 over 1 minus this common ratio x. We now have our very first function with its representation as a power series. The function 1 over 1 minus x has the power series representation n equals 0 to infinity, summation n equals 0 to infinity of x to the n. The requirement, though, is that x be less than 1 in magnitude. That's the only time that this function will equal this power series. Again, I want to make that note. So 1 over 1 minus x is equal to the summation n equals 0 to infinity of x to the nth only on -1 to 1. Now, because we have a function, I can graph that. I can go to Desmos right now and graph it and then graph the power series to see, is this actually true? And that's what we're going to do. Let's go ahead and go over to Desmos and do that. Let me just get everything set up here and share my screen. I hope you guys don't mind me using Desmos to showcase this stuff. I just love visuals. I think it's really neat. So here, let me go back to my standard screen. There we go. I turn on the function. There's our function 1 over 1 minus x. And again, we're saying that it should equal the power series x to the nth, but only from -1 to 1. So let me turn on my power series. I've only added up the first term, so it's a first degree polynomial. If I add up the first 2 terms, it's a second degree polynomial. First 3, 4, 5, 6, and so on and so forth. If I keep going, you can see it's at no point is it jumping over and hopping on the right branch. It's only staying on the left branch here, but it's definitely matching beautifully. And what is it matching up to so far? A -0.87 roughly. So if I add a few more terms, let's go to 50. Give it a moment because Desmos takes a while to do that. I guess it's done. Now we're probably out to -0.91 as far as how it's converging. So it takes a while. We still have to add a ton of terms to get a pretty clean level of convergence between -1 and 1, but it looks to be very convergent. It glues to that red curve pretty nicely between, it looks to be -1 and 1. And let me look really quickly. Perfect. Okay. So let's hop back to the laptop here. Let's dig this stuff. if you guys exit this course and go and talk to other students, and they say, man, you know what I hate about Calc 2? Power series. If you say, you know what, actually, I love that stuff, I'm gonna be so happy. This stuff is the cat's meow, bee's knees, right? All right. So that's all I had on this page. That this function is actually that power series on -1 to 1. A little note, since this power series is born of a geometric series, this is the case, and I'll just say the because it's the only case. It is the case where the interval of convergence will never include the endpoints because, again, it's born of a geometric series, and we know the geometric series will always diverge at the edges at -1 and +1. So this is one where you don't have to test endpoints. You just find the interval of convergence and you're done. You don't have to test endpoints when you're dealing with this style series. But you say to yourself, wait, but this is only one function. So why would I continually have to deal with it? I now know what that is. I can totally memorize. If I see f of x equals 1 over 1 minus x, and somebody says, what's its power series? I know it's a summation n equals 0 to infinity of x to the n. And I say, nope, you now have an infinite number of functions you can turn into power series. And you say, what? And I say, yep, absolutely. Why? Because let's find a power series representation for this bad boy. So this is f of x equals 2 over 9 plus x. It's not 1 over 1 minus x. Man, I wish it were 1 over 1 minus x. That'd be great. Oh, you know what? It almost is. It's like 2 times 1 over 9 plus x. Now, our goal, maybe I should write that down, is to get 1 over 1 minus something. Because I know that that is equivalent to that something raised to the nth power. I already have 1 over, right? It's 2 times 1 over. So let's see if I can make that a 1 over 1 and then eventually change that into a 1 over 1 minus. So let's see. I'd love this fraction to be a 1 over 1 plus x. So let's go ahead and factor off a 9 out of that denominator. Am I exactly at that blue ink yet? Not exactly, but pretty darn close. Can I change an addition into a subtraction? Sort of. I can write this as 2/9 times 1 over 1 minus a negative x over 9. Bam! I have now arrived at 1 over 1 minus happy face, where my happy face is negative x over 9. I now know it's 2/9 times the summation n equals 0 to infinity of, instead of x to the nth, I have this happy face, that variable, negative x over 9 to the nth. To be honest with you, not a lot of people are going to write it that way. You will often see this written slightly differently, just cleaned up. No calculus here. It's just a little bit of algebra. They'll write it as negative 1 to the nth, x to the nth over 9 to the nth. They're equivalent forms, honestly, so it's not that big of a deal to me how you write it, but there you go. So a quiz, just a quick, speaking of quiz, we have a quiz today, don't we? Yes, we do. Thank God I said quiz, right? We have a quiz today on 11.4. So it's just a heads up. Anyway, but a quick quiz for you to think about right now. What is the center of this power series? I'll give you a hint. The factor that has x in it, what turns that into 0? Is this thing on? Check. Is this thing on? Rubber baby buggy bumpers. Hello? Am I connected to my internet? Is the world out there? Please let me know that I'm not alone. Now you guys are making me feel like I'm alone. Hello? Is there anybody there? I got to check. Can you guys actually hear me now? Something happens. My whole thing locked up. Sorry about that. And I froze, right? Okay, perfect. All right. So let me go back to that was so weird. I don't know what happened. All right. Okay. So I'm just gonna erase this. I don't know where I lost you. Um, was it did you hear anything that what did I get you to that point right there? The center. Okay, thank you, Avi. So um I'm just gonna ask it because I can't see your previous chat. So so the center occurs when that factor is 0. So when is that factor 0? Hopefully I don't freeze again. You should have heard me. I was talking to myself like for a long time. Am I still okay? Good. 0. Yeah, exactly. So the center of this power series is x equals 0. You were with me while I was driving everything else, correct? Like you were with me up until that point, hopefully. Okay, perfect. Man, I get excited. I must have been so excited. My energy just blew up Zoom. There we go. All right. So we have found the power series representation for something that wasn't 1 over 1 minus x. It was 2 over 9 plus x. And you say, well, that's great, but that's just a minor change of our original series. By the way, we were supposed to find the power series and determine the interval of convergence. Because this whole power series is based on the geometric series, it only converges if the absolute value of negative x over 9 is less than 1. That's the only time it'll converge because it's based on geometric series. So if I multiply both sides by 9, terrible board usage, by the way. Sorry about that. If I multiply both sides by 9 and ignore the negative in the absolute value, I'll get that. So it converges on negative 9 to 9. You can easily see, by the way, the center is 0. Again, I could visualize this using Desmos, but I actually think I'm going to, instead of jumping over Desmos and visualizing this, I think what I'm going to do is just one last example because I froze and I want to do one more example. Every time I freeze, I'm just going to do an extra example. Oh, yeah, I should mention this. Not all functions have power series. I think I've mentioned that before, that not every function in this universe has a power series representation. Moreover, a finite polynomial expansion is not the power series representation. That should make sense. That is, 1 over 1 minus x is approximately equal to that third degree polynomial, but it's actually equal to the infinitely long polynomial. Let's use Desmos to visualize this. I will at the end. Actually, we already did. now that I think about it. We already went to Desmos and graphed this specific one. So let's do one last example. It looks terrible, right? Find a power series representation for the function. Now, I'm just going to write in here a goal. We want 1 over 1 minus happy face, because we know that will be summation n equals 0 to infinity of happy face to the nth power. That looks like a confused face, but it's a happy face. All right, so let's go ahead and see, can we transform this function into a 1 over 1 minus? And the answer to that is actually, yep, you can. Series comparison, nope, you're not going to use anything like that. When you're transforming from a given function into a power series, you don't have to test it. No testing necessary when transforming from a given function to a power series. What you're going to do is manipulate the given function to where it's 1 over 1 minus something. So for example, I would like that fraction to be a 1 over. So let me factor off a 2x squared. That's pretty darn close to 1 over 1 minus. But it's not 1 over 1 minus, it's 1 over 1 plus. So I can rewrite that as 1 over 1 minus a negative. So I'll do that. And now I have it. I have my 1 over 1 minus. That picture, the 1 over 1 minus, there, I'll just zoom in. That picture right there, which is 1 over 1 minus a negative x cubed, is a power series. It's the summation. Let me just go ahead and write that. It's the summation n equals 0 to infinity of that picture right there to the nth power. But you would not answer it like this. You would actually clean this up. I'll start very slowly. I'll say that's a negative 1 to the nth. And then we have x to the 3nth power, right? Powers to powers multiply. So x to the third to the nth is x to the 3nth. And you're still not done. What you're going to do, you can leave the 2 out front, but you're going to bring that x squared inside. And you will be done. This will be negative 1 to the nth, x to the 3n plus 2. That is the power series representation of that fraction, 2x squared over 1 plus x cubed. And again, I'll ask you a question. Where, I suppose I should say, how will you, well, it would take a lot of typing for you to say. So I'll say it. If I'm dealing with a geometric series, like this guy right here is a geometric series, something to the nth power, you know it will only converge if its argument is less than 1 in absolute value. So we require, let me use blue for this, we need the absolute value of negative x cubed to be less than 1. Well, that's the same thing as saying x, the absolute value of x being less than 1. Try it out. So our interval of convergence will be negative 1 to 1. Again, because this is born of a geometric series, you will not have to check the endpoints yet. But yeah, you will not have to generally check them. I do want to go ahead and show you. Oops. Oh well. I'll go ahead and show you right now the Desmos version of this. So here was our 1 over 1 minus x, and we summed up the first 50 terms, and I can just pull that back now. Now we're going to deal with 2x squared over 1 plus x cubed was our new one. And we're saying this is going to converge on negative 1 to 1. The power series representation that we got was 2 times negative 1 to the nth times x to the 3n I have to put a parenthesis here, otherwise it will yell at me, plus 2. Now, you had better believe that this works very nicely. Actually, look at this. So for a equals 1, in other words, I summed up n equals 0 to n equals 1 here. And look how clean that already matches with just the first 2 terms, the 0th and the first term. And look how nice that's matching. If I get maybe to the 6th, it's actually the 7th term because it starts at 0. Look how clean that is. How many terms did I need to add up? 7 terms to get to that. That is really brilliant. What a great, by the way, notice I keep adding and it's not really getting me any extra edge here. It's just locked in right around 1. So there we go. That's pretty convincing that our interval of convergence doesn't extend beyond 1. Really a very, very nice problem. Let me hop back so that I can see if you're saying anything, because I can't see it when I come back here. All right. So it is now 8:51. I should let you go. Remember, we do have a quiz today on section 11.4. It'll be open all day, starting at 10. And I will be in my office hours in 9 minutes. I hope you guys have a wonderful weekend. Rock on, go mathematics. I'll see you guys in a little bit if you're going to be in office hours. If not, have a wonderful weekend, everybody. Thank you for being awesome. You're good students. I really appreciate you guys. So take care, and I'll be back, like I said, in about 9 minutes.